We're going to be talking about exponential and logarithmic equations today. Again, it's going to be a very quick lesson because you guys will remember most of it from previous years, right? So an exponential equation, right, basically is an equation that contains a variable as an exponent, right? And so take a look at these two different ones. Like here you have two bases on either side with variable exponents. Here you have one base on one side with a variable exponent and then not on the other side. So when we have this second case here, it's kind of easy. We use what we call the one-to-one property. Basically, if we write the left and right in terms of the same base, we can just set the exponents equal to each other, right? So here you have a base of 4 and you have a base of 16. Now, all you need is for those two to have the same base. They don't necessarily have to be like the simplest, most elemental base, right? So it's enough to make them both 4 to the power of something. So if this is 4 to the power of x minus 2, x plus 2, this is 4 squared to the power of x minus 3. So x plus 2 is 2 times x minus 3. So x is equal to 8. Okay, now, what is the domain of exponential functions? All real numbers. So there isn't an issue of extraneous solutions here that you have to go back and check for, okay? All right, here, 2 over 3, right, and 9 over 4. So I'm going to leave this as is, but the 9 over 4, do you see how this is equal to 2 over 3 to the power of negative 2, right? So not only is it squared, but it's also the reciprocal to the power of 3x over 4. Okay, so now I'm going to set those exponents equal to each other. Oh, what happened there? Mind of its own. Okay, so x minus 5 is equal to negative 2 times 3x over 4. X minus 5 is equal to negative 3x over 2. And then let's cross multiply by 2 on both sides. 2x minus 10 is negative 3x. So negative 10 is equal to negative 5x. X equals 2. Right? Questions? Okay, so these two divide, so this will be a 2. So now it's negative 3x over 2, and then to get rid of that 2, I multiplied both sides by 2. Okay? All right. Here, I only have the exponential form on one side, right? That means I'm going to solve this one using a logarithm, right? We have a base of 4, and x is the exponent. So basically what I'm going to do is I just take the logarithm of both sides, right? So it's going to be log, what's the base? 4 of 4 to the x equal to log base 4 of 13. You have to take the log of both sides. So on the left side, what do I have left? X equals log base 4 of 13. And if this was a non-calculator part, you would just leave it as is. This is okay. This is good enough. But if it is a calculator part, then you have to plug it into your calculator. And we normally go to 3 decimal places. So this would be about 1.850. Yes? I thought you were just supposed to do why is it log of both sides? Because this is an equation. You have to keep the equation balanced. Whatever you do on one side, you have to do it to the other side as well. Yeah, but can't you just make it log base 4 of 13 equals x? Right, and initially that's what happened. If you want to do that from the beginning, you can see that and do it from the beginning. You're more than welcome to. Okay? All right. So here we're going to take, again, log base e of both sides, which is like taking ln of both sides. So ln of e to the 2x plus 1 is equal to ln of 8. 2x plus 1 is equal to ln of 8. 2x is equal to ln of 8 minus 1. Okay, you can't make that ln of 7 because ln of 8 is one quantity. And then x is that whole thing over 2, right? So you can either put the ln of 8 in parentheses or you don't have to. They are both equally okay, all right? So that's number 1. Number 2, now let's go into logarithmic equations. Logarithmic equations are the same thing. If I have a logarithm on both sides, then I can just set their insides equal to each other. If not, I have to use the exponential form. Okay, so take a look here. The first thing you want to do is isolate the log or ln. So divide by 2. ln of x is equal to 9. Now, when I have something like this, a logarithm equal to something, I always like to use the properties of logarithms. So what have we been saying this whole time? What is the answer to a logarithm always? An exponent, right? So here, 9 is the exponent. Well, every exponent needs a base. What's the base in this problem? E. So I say e to the 9 is equal to this number, x. Okay? So always use that property because it's just so quick. It makes you look so savvy, right? Like get invited to all the good math parties, right? So that's how we do it. Now, x equals e to the 9th. It's too big a number. So we can just leave it as e to the 9th. In general, if you start going like past the thousands, like if you start getting into like the 10,000s, don't bother simplifying. Just leave it as like a power, okay? All right. So here, we're going to subtract 7 from both sides. So we get negative 3 log 10x equal to 6. Divide by negative 3. So log 10x is equal to negative 2. Now again, here I have a logarithm. What is the exponent in this problem? The negative 2. Whoops. Okay, every exponent needs a base. What's the base here? 10, but it's this 10 here. Okay, so this 10 to the negative 2 is equal to what? 10x. Okay, but now you have to simplify, huh? So now you have to simplify. So 10x is equal to 1 over 100. That's what 10 to the negative 2 is, right? Divide by 10, that's like multiplying by 1 over 10. So x is 1 over 1,000. Okay? Or you can write x equals 1 over 10 cubed. It doesn't matter. Okay? Just don't put any negative exponents. Questions? Okay. Here, this is like the easiest case because you have identical logarithms. It means you can set their arguments or the insides equal to each other. And look, it becomes everybody's favorite, a quadratic equation. Yay! Okay, remember, anytime you want to solve an algebraic equation, you set everything to the same side and you set it equal to 0. And then we can factor this. So x equals negative 5, x equals positive 4. Okay, now, one thing I've neglected to mention is the domain of logarithms all real numbers? No. So you should check that your solutions work. Now, normally if you just get one solution, that's not a big deal. But if you get more than one, there is a chance for extraneous solutions. You have to make sure that when you plug these into your original equation before you got rid of the logs, okay? You can't plug it in here. Everything will work over there. That's a nice, cute quadratic. When you plug your values in here, left and right should match, and also a big, like, red flag is you can't have any negatives inside the logarithm. All right? So a negative number might be okay because you'll square it when you plug it in here, right? So that'll be okay. So let's check this. If we plug -5 in here, does -5 work?
No. Yes, it does. You get 25 minus 5, which is 20. It's log base 5 of 20.
Right. They both work. Right, and x equals 4 also works, so both of these are answers. Okay? Don't judge a book by its cover, right? Always check. Okay. So here, okay, what are we going to do here? Do you guys remember? Okay, so you have a log there, which is fine. You have 2 logarithms here, so you have to condense first, right? Okay? So condense first. So log base 2 of 5 is equal to, here, this will be log base 2, 10 over x minus 4, correct. And now we can solve them because we can set them equal to each other. So 5 is correct. And if I cross multiply, 5x minus 20 equals 10, and it looks like 5x is 30, and x is 6. And always check for these, right? Because you did like so many, theatrics here, right? So always make sure that it's all going to turn out fine. Now, to check, you can either plug it into the original or you can plug it into here. They're both okay, but not after you got rid of the logs. Okay, if I was doing it, I would probably do it in this one, right? So does it work? Yeah. Yes. Okay. So it does work. Okay. This one is really not a big deal. I put it in here because it shows up a lot in calculus again. Okay, you have this equation. You want to solve it for y, right? Here is the y over here, right? So how are we going to do this one? Here you have a logarithm. Yes, a logarithm equals to something. Remember, the answer to a logarithm is always an exponent. Every exponent needs a base. What's the base here? E. So e to the power of -5x plus 3 is equal to what? Y. And that's it. That's all. That's literally all. People just get so confused when they see this in calculus and they're like, we never did this. And this is here. This is me telling you, you did do this. So remember next year when you freak out. Yeah.
How do we know when to plug it in?
I mean, it won't be an issue because normally, like, it'll say around your answer to something, right? Owen, did you have a question? Suppose I gave this to you on a test or on a test, and I made it a multiple choice question, okay? I can write the answer to a multiple choice question in any format that I can, all right? So what if I simplified this further, like you guys did in the lesson, in the worksheet for today, and I wrote this as y equals e to the -5x times e to the 3, right? We can do that, right? And what's e cubed these days? Do you guys know? So apparently it's 20.1. So e squared is 7.4. This I just know because I know. And then e cubed is 20.1. So I can also write this as 20.1 e to the -5x. So look, this, and this all are equivalent statements, right? So let's say in calculus, okay, if you have something like this and you have a multiple choice question, the answer can be written in any of these forms, and you, the sophisticated math student, should know all of those are equivalent forms. All right? Right? Okay. Okay, these are my absolute favorite because they are not boring like the other ones. Okay, now we have different bases on each side, so you can't simplify them. That means we can still take logarithms of both sides. We can use, like, remember change of base formula from last year that nobody really remembers because we just do it in 2 seconds. So basically, you can write both of them in terms of the same base, a different third base. And everybody's favorite logarithm is ln. Let's just face it. Okay, so what we do in this case is we take the ln of both sides. So now I have ln of 3 to the 6x minus 3 equals ln of 2 to the 4 minus 2x. Oh, now, property of logarithms, exponents always move down, right? So this is going to be 6x minus 3, in parentheses, of course, ln of 3, equals 4 minus 4x, in parentheses, ln of 2. Now, I'm going to distribute the ln's into their respective buddies. So, I get 6x ln of 3 minus 3 ln of 3 equals 4 ln of 2 minus 4x ln of 2. Now, what are we doing in this problem? What are we solving for? X. So that means at some point, not that there isn't much left to do, I need to collect all the terms with an x to one side and everything else to the other side. So to do that, where's my, oh. Okay, to do that, here's what I'm going to do. So I'm going to bring this to the other side. So it's going to be 6x ln of 3 plus 4x ln of 2 equals, now I'm going to take this to the other side. So it's going to be 4 ln of 2 plus 3 ln of 3. I haven't done any math in this step. I just rearranged the equations. Now, can I factor out an x? Yes, of course. So I'm going to factor out just one x. So 6x ln of 3, I'm sorry, 6 ln of 3. You can, but let's not. Go with me on this. Okay, because you're going to have to, eventually you're going to have to like take the x back, the number back out of there. Plus 4 ln of 2 is equal to 4 ln of 2 plus 3 ln of 3. Now, okay, hang on. So now x is equal to, now we're going to divide by the parenthesis, right? So this is going to be 4 ln of 2 plus 3 ln of 3 all over 6 ln of 3 plus 4 ln of 2. Okay. Whew, we solved for x. But now let's simplify this, okay? So this is going to be ln of 2 to the 4 times 3 cubed, right? When you condense, remember like you did yesterday? Over, so I'll put that in parentheses, over ln of 3 to the 6, 2 to the 4. Okay, so Ben, you've got your calculator over there? Okay, so 2 to the 4 is 16 times 3 cubed. What is that? Quick, putting you on the spot. 16 times 27. 432. Okay, so this is ln of 432 over, all right, you want to help me out with this one? 16 times 3 to the 6. Okay. Okay. My fourth grader would ask me to put a comma there. So, okay. So now look. First, do not cancel out these 2 to the 4th. Please don't do that. You can't do that, right? Okay. Next, I'm actually fine with this step. Okay? Because like I said before, once you get past the 4 digits, I don't need you to write all these like random digits. Okay? The book is definitely gonna have it all simplified out like this. I'm fine with this step. Okay? Yeah.
Why did you cancel out the 2 power 4?
Because those are arguments inside the ln, and you can't do that. It's just like if I had the square root of 3 over like if I had the square root of like 3 plus 2 like this, okay? And if I had the square root of, I don't know, 9, could you cancel them out? No, right? So they're inside, or let me give you another example. If you had sine of 2x, okay, over, let's say, sine of 4x, would you be able to cancel the 2 and the 4? No, it's a similar thing, yeah. Okay. This is fine. Okay, let's do this next one super quickly. All right. So we take ln of both sides. So it's ln 6 to the 2x plus 4. We did this last year. Do you guys remember? Yeah. Okay. So take ln first. Now bring down the exponents in parentheses. Distribute 2x ln of 6 plus 4 ln of 6, negative x ln of 5 plus 1 ln of 5. Now what? X ln of 5. Correct. Collect all of the x's on one side. Oh, no. This is, okay. This is minus 4 ln of 6 plus ln of 5. All right. So now, factor out an x. I have 2 ln of 6 plus ln of 5 equal to, okay, this is where like the math me gets in the way. Whenever I have a negative term and a positive term, I always write the positive term first. I'm just going to swap those terms so the negative is like contained inside the expression, right? So I'm just going to swap these terms, ln of 5 minus 4 ln of 6. So now x equals ln of 5 minus 4 ln of 6 over 2 ln of 6 plus ln of 5. So this is ln of 5 over 6 to the 4, right? Over ln of 6 squared times 5. You can leave it like that. So this will be what? ln of 5 over 6 to the 4. This is a small enough number that I think I'm just going to multiply it out. What is 6 squared these days? 36 times 5. How much is that? 180? Okay. Now, a word, one other thing. Okay. You see how here I brought all the x's to the left side and all the other numbers to the right side? If you do the reverse order, if you bring all the x's to the other side and so on, then do you see how like each of these will be the negative of itself? Yes? That means over here, there'll be, instead of ln of 5 over 6, you'll have like this, but it's okay, right? Because this is just to the power of minus 1, right? And then this is also to the power of minus 1. So they all cancel out. So just know that that's okay. So in the book, if both of these are reversed, then it's okay. All right? Okay. Next, let's move on to bigger and better things. Okay. Here, this is quadratic form. This is similar to when we had the sine and the cosine. All right? So we're going to factor this. But instead of x and x, we're going to put e to the x, e to the x. Okay? Does that make sense? When you multiply those two, do you get e to the 2x? E to the x, e to the x, e to the 2x. Now, how do you get negative 2 when you multiply two numbers, but negative 1 when you add them? Plus 1 minus 2. Okay? Now, set each of these equal to 0. So you set this one equal to 0. You get e to the x equal to negative 1. That doesn't exist. So now, if you can't see it, to solve this, you have to take ln of both sides, which means you get x equals ln of negative 1, which doesn't work. Here, e to the x minus 2 equal to 0. E to the x equals 2. Take ln of both sides. X is ln of 2. That's a good enough answer unless the instructions say for you to put it in decimals, and then it's 0.693. Okay, here, add 3. Okay. Divide both sides by 40. So I get e to the 0.6x is equal to 60. Now what? Oh, 6. Now take ln of both sides. So 0.6x is ln of 6. X is ln of 6 over 0.6. In a situation like this, we never leave it that way because you should never have a fraction with decimals inside. That's a complex fraction that is not simplified. So we just plug it into the calculator and we get 2.986. Okay. Oh, okay. Okay, what do you guys suggest we do here? Combine the ln's. So ln of 7x plus 3 over x plus 1. Ln of 2x. Then set the insides equal to each other. Cross multiply 2x, x plus 1 equal to 7x plus 3. Okay, so if we distribute 2x squared plus 2x, equals 7x plus 3. Bring everything to the same side. Minus 5x minus 3 equal to 0. So 2x and x. I feel like I want to put a negative 3 on the second one and a plus 1. Right? So what's x equal to? Negative a half. And x equals 3. And then you have to check. Right? So already it looks like the x equals negative half isn't going to work, right? Because when you put it in there, you're going to get ln of a negative number. Okay? And I think the 3 works. Okay. Okay, lots of random things in this chapter. This is another random thing that I've noticed sometimes, my students have done this so long ago that they forget how to do this by hand. You should be able to, simplify things like this by hand, right? So, and again, several ways of doing this. But if you have something like this, this is the square root of 27 cubed, right? Or it's the square root of 27 cubed. Both of these are equivalent. And then it's up. the square root. And then it's up to you, right? Whichever one of these you want to solve. Obviously, this is easier to solve, right? So whichever one you want to do. So this first one, the square root of 27 is 3 root 3 cubed. Okay? So this is 27 times root 3 cubed. But how much is root 3 cubed? So take a look. This is 27 times, root 3 cubed is root 3 times root 3 times root 3, right? Let's see, root 3, root 3, root 3. This is 3 times another root 3. So that will be 81 root 3. Okay? Again, we do this in algebra 1 and algebra, then, we kind of get out of the habit. Okay, this one is the square root of 12 to the power of 5. Okay, root 12 is 2 root 3 to the power of 5. And, this gets distributed to both. So 2 to the 5 is 32. Okay, root 3 to the power of 5. You've got 5 of them, right? Each 2 gives you a 3. So 3 times 3, 9 times a root 3. Okay? If you get confused, write it out. Okay, so there is a mantra that says, when in doubt, write it out. Okay, so 5 root 3s. It gets to be a problem when you have like 17 of them, right? This is a 3. This is a 3. Okay? And 32 times 9, it looks like is 288. Okay. Let's talk about coffee. Okay? Okay. So the price per share of a coffee chain stock was 93 cents in January of the first year of trading. In January of the 5th year of trading, it was 3.52. So definitely there is some growth here, right? Exponential growth. So now look at this one. It says to write a continuous exponential function. Do you see where the word continuous comes in? So it's going to be e to the kt instead of anything else. To model the price of the stock P of t as a function of the year of trading t. Okay, so the fact that it's a continuous exponential function is y equals y naught e to the kt. All right. In this case, it's going to be P of t is equal to P naught e to the kt. All right. So final amount was 3.52. Initial amount, 0.93. E to the k times how long did it take for this to happen? 5. Okay, so now I'm going to divide both sides by 0.93. So I get 3.7, what is it, 85? Or is it 55? Okay, I'm actually going to, let's see, I'm going to actually plug this in. So 3.52 divided by 0.93. Oh, yeah, 3.785. Okay, but again, I'm going to use the unrounded in my calculations, right? So this equals to e to the 5k. Take the ln of both sides. So I get ln of 3.785 equal to 5k. K is ln of 3.785 over 5. So here, take a look. I'm going to do ln of the answer. Oh, what happened? over 5. So this is 0.26621. What does it say to round to? Nearest thousand. So how many is that? Right. Okay. Now, okay. Use the model you found in part A to predict the price in a company's 9th year of trading. So when T is equal to 9. Okay. To do this, first let's write the... Oh, wait a minute. What did this question ask for? It says it wants the equation. So P of T is equal to 0.93 e to the 0.266 t. Okay. So here in the 9th year when t is 9, I want to find P of 9. Let's write that in proper notation. P of 9 is 0.93 e to the 0.266 times 9. So P of 9 is going to be, I'm not going to round, right? So it's going to be 0.93 times E. Hang on, sorry. E to the power of the answer times 5. No, times 9. What happened? Huh? So it's 10.21. Okay, what is this? This is the price, right? So you have to know to round it into dollars and cents. So it's going to be 10.21. Now, if you were rounding along the way, you weren't going to get 10.21. You would get 10.19, and that would be the incorrect value, right? So on the test, there's going to be only one correct value, and that's going to be the unrounded version. All right? Okay. Ooh, we finished the chapter, guys. Oh my gosh, how happy are we?